Welcome to my algebra class. Let's go ahead and read this problem. Owen found a deal on an Android cell phone case. It was only $10.50, but that meant that he had to buy a phone that fits the case. He finally found one at the same store, and it was half off the original price. What are the odds of that? His total for both items came to $123. Using an algebraic equation, what was the original price of the phone? So when we look at a problem like this, we always want to ask ourselves, okay, what is it that they want? That's usually our first question. So they want the original phone price. What was the original price of the phone? So then our next question would be, well, what do we know? Well, we know that the phone sale price was half of the original, and that is up here. He found one at the same store, and it was half off the original. And what else do we know? We know that the price of the case was $10.50. The case price was $10.50. And what else do we know? The total he paid was $123. The total that he paid was $123. So what can we do with these items that we know and find the original phone price, which is what they want? Well, why don't we go ahead and describe this equation in words without even using numbers? So if we did that, would we have an addition problem, a subtraction, multiplication? We would have an addition problem. And that problem would be the phone sales price plus the case price, the phone case price, equals the total that he paid. So let's go ahead and fill those in with what we know. And we know we're going to have a variable somewhere, and we just have to decide if our variable's going to be the original phone price, or is it going to be, say, the sales price? Because either one we don't know. And we kind of want to, usually, you go with what they want. That's usually your variable. Usually, not always. And you kind of want to take the one that's going to require less work, less steps. So if we were to describe the phone sale price as half of the original, well, we could just call the original then our variable. So half of, say, our original is x. So then we could say, well, our phone sale price is 1/2 of, and of usually means multiply, 1/2 of x. And then the case price, well, we know that is $10.50. So, and then the total we know is 123. So let's go ahead and write that. So let's go ahead and rewrite this in red up here, just so that we have it. So that's our formula that we're going to fill in with what we know. So the phone sale price, we can see that our phone sale price down here is 1/2 of the original, which we said was X. So 1/2 of X. And remember, this X belongs in the numerator actually, plus the case price. And the case price we were told is $10.50. So I'll just put 10.5 equals, and then the total paid we were told was $123. So now we just have to solve for X, which is our original phone price, which is what they wanted anyways. So to solve for X, we have to isolate it. So first we'll get rid of any other terms. So this 10.5 needs to go to the other side of the equation by adding a negative 10.5 to both sides. So we end up with 1/2 X on this side. And then we end up with 123 minus 10.5 on this side, which results in 1/2 X equals 112.5. And now we have to further isolate X, so we'll multiply both sides of the equation by 2 to get rid of this denominator here. So I'll just write that in so it's very clear. We'll multiply 2 on this side and 2 on this side. And remember, if we do the same thing to both sides, we still retain the equality of the statement or equation. So 2 times 1/2 is just 1 times X, which is X. And then 112.5 times 2 is 225. So that means that 225 is the original phone price. So let's check and see if that works. If we took 1/2 of this original 225 and we added that to the 10.50, does that equal the 123 that he paid? Well, let's see. 225 divided by 2 is 112.5 plus 10.5. And does that equal 123? Absolutely. 112.5 plus 10.5, 123 equals 123. So this is indeed our original price of our phone. Yay, we did it.